everybody. Hello. Okie dokie. So I have put together all that we learned in the 18 months that we tried to do what we thought was impossible and managed to get it right. So I hope to leave you with, if not a game plan, but certainly the open source tooling that bootstrapped and cut 30 to 90, 30 to 90, but a fair whack of the effort out of the equation and set us up for success. So, good afternoon. So, help, I need a PaaS experience on Kubernetes, so Platform as a Service experience on Kubernetes yesterday, also known as my production environment is a ball of mud and possibly on fire. So, the original title of this talk was Paving a Path. We're talking about the application developer's deployment path to production. I'd like to frame this as a case study, what we at a past employer set out to do and what we achieved. And I'll share what worked and then give, as mentioned, pointers to the particular open source tooling that was very helpful. Or at the very least, give you a sense of the complexity and the size of something of this impact to an organization's coding, behavior, and their culture. So our aim was to help R&D go fast, to unlock new territories for the company by quickly spinning up new production environments. So we had an established United States data center hosted SaaS application. For people in Europe, it won't be a surprise to you to hear that there are European countries that cannot use SaaS software hosted in a US data center because of data residency sensitivity. So we had a massive backlog of millions of sales deals that were blocked because we did not have SaaS hosted in the EU. And that was that was all the political capital that we needed to do this work to enable us to reproduce what we had in GCP in the United States and establish the same functionality hosted in AWS in Europe. So when I refer in this talk to Polaris, it will be in reference to our internal project name. We established a very thin platform as a service API across several Kubernetes with very little code that we ourselves had to write. We just had to design conventions and then leverage open source to make those things real. Let me go. So a bit about me. So as mentioned, 16 plus years as an engineer, did a master's, discovered that product management is a thing and important because you can end up spending a lot of time building something no one wants. And in one of the companies I worked for, Pivotal, there was an opportunity to step into a product management role in a platform team, and that was all I needed. So that was an open door to doing something that I care about, is making sure that we, software engineer for a while, PM for 6 years, doing platforms on Cloud Foundry and then on Kubernetes. So I saw how that world shifted. A bit about this talk. So as I mentioned, it's the story of Polaris. Polaris had a lot of impact on the organization, so it can be spoken about in many different lenses. We can talk about its component parts, its architecture. We can talk about the philosophical approach. Like how much do you restrict your engineers? How much do you empower them? And most importantly, I think the thing that we learned was how you win hearts and minds. So you can go off in a dark corner and build something amazing. There's no guarantee that people are going to prioritize that and use that. So the art of internal developer relations showed its strength in this, in that we needed to make sure that not only were we doing it, but that people were seeing it, people were getting value from it, and that it was consistently used throughout about 30 R&D teams with around us in the company. So our 18 months of intense learning can't all make it into these 40 minutes. So I'm going to be selective and share what I believe could help you, particularly the open source that we used, as well as some of the more tricky learnings. So I interviewed the architects, the engineering directors, the managers, and the engineers of the infrastructure group that I was the product manager for, to give a sense of all of our shared experience on what we thought made this work, in the hopes that that helps you. So, over the places we will go. So that is Dorothy, the Tin Man, Lion, and Scarecrow on their road. And on reflection, for us to pave this path, it took a lot of courage, a lot of smarts and experience, and a lot of heart. It was very difficult. It was hard. And the chatty ones who drew attention to where we were going. I want to talk about what our cross-functional team at 18 months into this journey believed made this succeed. Success and buy-in involves storytelling, multiple modes of communication, forcing functions like deadlines, a couple of false starts along the way if you learn from them, and a clear shared mental model. Not everybody in that company is going to be an infrastructure platform-esque engineer like we are. So some of the concepts and the terminologies and the concerns that we hold are not familiar to application developers, and they might never actually care. They don't necessarily need to know or want to know. So it's how do I make sure that I give you enough to empower you to be independent, but obscure the things that you shouldn't really need to worry about. So today, I'm going to touch on the problem and the opportunity, describe Polaris and what a Polaris resource is, describe what we mean by a paved path. I'm sure it's familiar, but just for the avoidance of doubt. Do a very quick whistle-stop tour of our journey, so the timeline and the timelines we hit, and then the important, probably more valuable anchoring concepts like what was the layers model that we developed, what guided us in technology selection. Open source is a big, beautiful universe of lots of shiny things, some of them abandoned. So how do you quantify and assess something that you can trust to build something like this on? The importance of socializing and driving adoption, as mentioned. You can build it, but no one is necessarily going to come. And then close with some learnings. Where did things get difficult? What worked particularly well? And what would we do differently? What's next for Polaris? And then finally, the links to the open source building blocks that we used and found great value from. So the problem and the opportunity. So when we're talking about 3 years ago now, the team was created, and it was one fearless engineering director, Crystal, and her 2 platform engineers. And they were running around, putting out fires in production on an estate that none of them had had experience building. And they were being the support personnel helping other people put out fires in their services and prod. So it was a bit wild in the beginning. 2 years later, R&D had tripled in size. So now we're talking 300 engineers with 2 support platform engineers and a director. And that, together with the growth and ambition of the business, meant that something needed to change, something needed to give. And that gave us enough political capital to actually get the investment to hire headcount to get 6 very, very skilled platform engineers in the room who have done this before. And just that wisdom and experience of having done it before gave us the head start to not make some of the obvious mistakes. So we needed a highly repeatable platform. We needed to leverage R&D-wide conventions and practices to make it less difficult to operate. It needed to be fast and easy to roll out new production instances. We rolled out, a year after starting, we rolled out the EU footprint service offering. A couple of months later, we rolled out APJ, so Asia Pacific. The opportunity, why are we doing all this work, was the untapped total addressable market. So millions of dollars, euros of accounts were held back until we could get these things done. Okay, so what is Polaris? Polaris is an internal developer platform for managing numerous production environments. We present a PaaS-like interface. I think if you have ever worked with Cloud Foundry, the CF push model, we needed to replicate something as similar to that, but on a Kubernetes infrastructure without this massive investment on tooling built on top of Kubernetes. We didn't want that. We just wanted it to be as easy as possible for the application developers to deploy and not have to worry about the things that we will take care of. It's our platform as a product. It is an opinionated way of using the tools that we provide and enables repeatability, so the ability to make new instances quickly. We provide common open source tools, occasionally vendor software, and then most importantly, the opinionated way of how to use them. That's the thing that lets you go from 1 prod to 10 in 18 months, which is what we did. Polaris is successful not because we use something like Argo CD, it's because of how we use it. Similarly with Circle CI. These are common tools, but I think with a little bit of savvy, we were able to make it best support our use case. What else? Other examples that we used would be Terraform Cloud. Polaris supports the full software developer lifecycle, including bootstrapping, repos, build pipelines, etc., and touches on everything that happens after a pull request is merged. So what is a Polaris resource? Again, back to this model of our use case, our clients, our application developers. They're building things that run on Kubernetes, which is there be dragons. For some of them, others are, it's down to the individual, but really you want to take that cognitive load away from a specialist who is doing something else. So Polaris built the capability of defining infrastructure within your application Helm chart. Not through anything particularly sophisticated, but the fact that we were maintaining the Helm charts for things like an S3 instance or whether it be AWS or GCP instance of a database, all the application developer needed to know or care about was defining that they're using a Polaris database. That would pull in the appropriate Helm chart, and that's the last they had to think about it. Who owns or maintains these resources? Funnily enough, this is actually an important thing to get right, because I mean, I'm guilty of it. It's very easy to play with something and then throw it over the wall to someone else who now needs to run it and walk away. And the risk there is that you have a specialist team who are there building your Polaris, and suddenly there's a mountain of things that people have abandonware that they want another owner for. So we defined the practice that we will own anything that has like over 80% adoption in the companies. So a database, a Redis instance, those things are commonly used, we will maintain those charts. If you have niche things that you need to use, the creation and the maintenance of that would need to then remain with you until such time as there's wider adoption. So that ownership model was pretty key. So what do we mean by a paved path? A paved path is a well-trodden, well-supported, well-lit route to production to allow app devs to move quickly. As an engineer who writes application code, I want to write the code and ship it. Logging and databases should not slow me down. I shouldn't be caring about that. Things on the paved path are smooth, and they are signposted. There are docs, and there are people to help you. And what is the intent of a paved path? It's to make things easier, to reduce the toil, to create consistency, both for the application and the platform teams. Work being done by a central team means it's done in a consistent way. It's the same type of thing going out into production when it's instantiated. It lowers cognitive load for people both on dev time, so day 0, and on day 2. It's just, you know what you're running. The intent is to build, in the words of one of the engineers, the path from code to profit. We started work in May of 21. 5 months later, we had our first pre-prod. 2 months later, we had our first production customer. 6 months after that, we had our first European data center installation. So within 12 months, at the breakneck speed, we got there. So those are the external milestones affecting customers. Internally, we would have had the internal roadmap for the application developers. So I think this is probably where things start getting a lot more interesting. So the layers model, like I mentioned, we had 2 classes of specialists in the room. You have your application developers and everything that they care about, and then we had the platform engineers, and there was no shared language between the 2. And even within the infra group, designation of some of the layers in the stack were ambiguous. So someone took the time to just sketch out a schema of how we understand all of these technologies and what it is that they take care of. So from containers down, for myself, maybe as an engineer way back, beyond containers, it starts getting murky for me. When I was even in Cloud Foundry land, I didn't really have to worry all that much about networking, so why do I need to worry about it now? So this just helped us at least have a handle on what it is we're talking about. So created that ubiquitous language. So just referring to the triangle on the screen there. So from the bottom, that would be RBAC, backup, audit, cost management. A layer above that is the cloud provider account and identity and access management. Above that is the network layer. Above that is Kubernetes. Above that is the APIs that we exposed as the infra group. And then above that, layer 5, conceptually, would be where the application and service authors would be deploying their code. So tech selection. How did we choose what to compose Polaris from? So we had a very experienced team. These would be their second or third systems that they're writing. They know what worked for them. But where there was ambiguity, kicking the tires. So hackathons, bake-offs, assessing support contracts, how easy it is to get something done, how easy it is to operate. So only when necessary, where there was any kind of debate, we would have a bit of a go play with it and see exercise with a couple of the engineers. K8s was the common denominator. So for the curious, what did we end up using? Usual suspects, so Helm, Argo CD, Terraform, Kubernetes, Docker, Prometheus, and vendor software would be GCP, AWS, CircleCI, Datadog, Backstage. A good example of one of the choices that we had to make was whether or not to use HashiCorp Terraform or use Crossplane. And in the end, we went with Terraform with the intent that we would give the application developers the flexibility to use Terraform if they so desired and not have to learn a new technology. So let's talk about, this is I think where we learned our biggest lesson. You can build it, but will they come? So let's talk a bit about the role of docs, demos, and onboarding in socializing and driving adoption. Not everybody has to use this. So you kind of need to, you can't be bullying people into using something that sucks. So there was an effort to get some pioneering teams, get some early adopters in the room, get their feedback and make the necessary changes. Those teams, we would have company-wide retros every 2 weeks, or not retros, sprint demos. And people would make a noise about their wins. And we initially started making a lot of noise about Polaris. We got adopters, and then they started making a noise about how this was making their lives better. And I think that very virtuous circle built the momentum of adoption and helped us refine and improve the product. For one of the things we observed is not everybody's going to be absorbing information the same way. Not everyone's going to be joining those Zoom calls. Not everybody's going to be reading the Slack channels. So you have to repeat yourself, and you have to make sure that the message goes out across many different forms of comms so that you reach as wide an audience as possible. But it had to be deliberate. The change wasn't going to be accidental. One pragmatic thing we did, and I think it was a big one, was we just decided, given that we are the subject matter experts and we know exactly what we want you to change in your Helm chart, we're going to submit the pull requests for you to your repo for you to look, double check we didn't break anything, and then just accept it. So we wanted to save you the context switching and the cognitive load. So we were like, we'll do it for you, just accept it, and we were flying. And that meant that adoption was in a matter of a sprint as opposed to this long drawn-out saga of trying to train and teach people about technology they don't care about and changes that they would probably ideally not want to be making. Okay, so 5 slides to go. So where did things get difficult? Usual candidates, so deprecation. There were things already in place that people were familiar with using. They were not aware of where it was broken, but there were things that were significantly broken, and that tax was landing on us. So it was in our interest and in the interest of the wider organization to fix these things, but to get the political capital and the will for people to change things that they've been using was not an easy task. So deprecation, upgrades, and creating a shared sense of urgency. So this is my timeline, this is the organization's timeline being driven by infra, but the wider R&D organization has its own roadmaps and its own sense of priorities. So for us to influence that and change those priorities took leadership support. It actually took a bit more clout than we ourselves had. But that was a challenge to get that done. Case in point, we deprecated the original ball of mud deployer 6 months after its replacement had already been launched and was in place and being used by some teams, because there was just that people were holding on to something that they were familiar with and scared to step over the line. Okay. What did we find worked well? So the team being very cohesive and very experienced, they worked very well as a team together. I was the product manager and I joined after they had been struggling for a long time. And I think that the team needed a product voice to advocate and say no to a lot of people because the team was being pulled in a lot of directions. But ultimately, to see all of the conflicting requests being put on these people and make a decision and drive the picture forward, you needed one person to be that umbrella. Leadership backing us signaled that we had the blessing and the clout of very senior people in the room. And maybe slightly controversial, but that deadline of having a contract signed with the customer and an ETA of we want to move in January meant that these conversations stopped being woolly and abstract. It became very real. Like there's a contractual obligation here. Program management. So we needed to coordinate effort across 30 to maybe 30 plus R&D teams and ourselves. And there's no headspace in a single engineer or a product manager to do that. You need a dedicated function for that. And above and beyond the pull requests. The layers mental model helped us all speak the same language, and choosing to not be overly restrictive and not force engineers down a road, give them the tooling to enable them to build their own. So we would give examples of Circle CI pipelines, we would give examples of various configuration. Having done that, having decided that we were going to give you the demonstration of how to use this, gave a reference model for people to use quickly. Yes, and the seniority of the engineers who did it. So they had been, this is not the first time they faced this particular mountain, so they had a great sense of what to avoid. I would add one more thing that I didn't put on that slide, and it's resist the temptation to start from scratch. That was one of the, had we tried to build all of these things from zero, I think we'd still be busy. So use the things that are out there that can use the open source that's out there that's going to make this faster for you. Do differently. Difficult question. Well, I got a lot of different answers depending on who I spoke to. So one of the observations was I'm not the person I was when we started. So I've learned a lot as a result of the effort. But given who I was there and what I knew then, I think we made the right choices and we delivered on time. So I wouldn't second guess myself. I think with the limitations and the pressure we were under, we executed and we got it done. We had to get this out the door very quickly. But given the luxury of more time, what would we have done differently? Probably a bit more customer research, been a bit more engaged with the application dev teams as they were starting to use Polaris for the first time. We kind of fire and forget. Well, we created the get pull requests, saw a green build, and moseyed on to the next team. We didn't really sit and absorb in a world where perhaps these teams would have wanted to take a bit more ownership, we didn't utilize the opportunity to watch and learn and see where to improve. We were just running for the hills, right? We were getting this done. So had we had more time, we would have spent more time coaching to get fast feedback. Where to next? So the future for Polaris will be, today we are building configurability so that in a world of those application developers, they might not even need to care about the Helm anymore. They can just give us the configuration rules. What is the size of the database you want? Do you have any kind of replication rules, etc. So Circle CI, obviously, you build and deploy pipelines. Circle CI allows you to build something called an orb. That orb is parameterizable. So you can send arguments to that orb. This is how we implemented things like canary builds, or this is how we will implement things like blue-green deployments across a fleet of Kubernetes clusters where we're like, it works here, I feel safe to roll that out to everything in EMEA. I now feel safe to roll that out to everything globally. So those kind of controls you would implement in an orb. Helm allows you to declare dependencies, and on the next screen I'll show you, it's not rocket science, but it was just how we used it. Once. Okay, so you are seeing there an example application, and we are declaring dependencies, Polaris Postgres being one of them, the alias is Postgres, and the repository is something external. That meant that we could designate that work to a separate team and just blindly use it by the consuming team. So any single resource can be implemented by us and then pulled in by an application team. So some of the pull requests that we might have done would have been something like that. So let me take this work out of your headspace. I will do it for you. You just run your service after you've brought in the merge and see that I haven't broken anything. Alrighty. So as mentioned, the value for us was in separating out the cognitive load. You don't need to care about your database, just tell me you need one, and I will make sure that it's there, whether that be on GCP or on AWS. Argo CD. Argo CD is gold, and I would highly recommend that you go read. So Argo CD, they describe themselves as a GitOps continuous delivery tool for Kubernetes. They describe it as the intent that application definitions, configurations, and environments, I'm thinking back to that ball of mud, should be declarative and version controlled. Another thing that they have, and there's a URL, so when you can take a photo, I hope you have, but it's called App of Apps. And that's a way, in a world of microservices where a lot of different teams are contributing code to different repos that together make the beautiful thing that you're building, the version of the code that's running in prod is identified probably by a get char. You need to know those things in an incident. You need to know what is running where. And App of Apps uses get chars to track what version of each service is running where, amongst other things. I probably can be corrected, but these were some of the tools that we used to understand the original ball of mud and make it understandable and reproducible, and then reproducible wherever we want, and done so quickly. Thank you. So yeah, have a look at the App of Apps pattern. HashiCorp, so the Terraform Cloud Operator, that's, let me read, they said it better than I can. It's a way to extend the Kubernetes, a way to extend Kubernetes so that you can use Terraform to build and provision cloud infrastructure. So you can create a custom resource definition, give it to the operator, and then tell Helm to use this particular CRD to go, please go build my database for me. So that was part of how we implemented, just the light touch. I'm an application developer, I need a database, I do not care how. That's how we made that work. Really helpful if I could, cursor. And then the last slide. Yeah, let me just read that for you. The Terraform Cloud Operator extends the Kubernetes control plane to enable lifecycle management of cloud and on-prem infrastructure. So it just gives you a lot more freedom. So have a look at that. I won't show you what we did because we were solving our unique business problems. But that should give you enough inspiration to get started. I did want to mention k8s. k8s is an open source tool that was built, started really taking shape after we had kicked off Polaris. Polaris is in-house and I think will always stay in-house. What I see in k8s is they're starting to build those capabilities that we built in-house and it's open source and you can use that. So if this is ringing any bells for you about pain that your users are experiencing, they might be able to help you. It looks very cool. So in closing, we got there, and the screen is on. All right, so in this Kubernetes as Lego IKEA world that we are now in, where you have to roll your own PaaS, you will need a solution that solves your internal developer community's problems. So this type of investment is expensive and disruptive, and it usually is an artifact of scale. This starts happening or being something someone's willing to part with money for is if deployment is getting particularly painful, which it was for us. It was becoming a nightmare. So it is most likely time when things are getting unwieldy to start hiring platform engineers and a product manager to start solving problems in order of priority and impact. So where do you start? You start, it's like going to a doctor's office. Where does it hurt? where are you going to move the needle the most, and therefore get goodwill, and therefore get further investment. So you start there. I think we got there, lads and ladies. There we go. So thank you. I don't know.
Debbie, do we have some questions for Debbie?
Or possibly a drink. No?
Oh,
No, I'm teasing. I've got
I
water.
see it on the far side.
Yes.
We've got a mic
Hi.
on that side.
Thanks. Hi, Debbie. So it was interesting hearing what you were saying about communication and the different channels and different mechanisms to communicate out.
Yeah.
One of the things I think platform engineering teams that do exist maybe struggle with is understanding just how much of the effort budget needs to go into training, education, documentation. What did you see in your experience as a sensible amount?
You know, I think that was some of the earliest feedback that was being given to us as a team, and I think it's a factor of how busy we were, was that we were working like, dwarves in Moria. No one knew what we were doing. We had to learn to become explicit, and we understood that if I don't write this down in Backstage, I'm going to get asked the same question about 40 times today. So we started making that a part of delivery. So one of the acceptance criteria on our story would be there is some sort of a how-to, and that how-to would either be discussed at the sprint demo weekly. So it was built into every story is the short answer. So if it was customer facing and there needed to be some level of training, one of the acceptance criteria was there's a section on Backstage that describes the why, the how, and the who to chat to, worst case scenario.
But there's also a burden to maintaining that documentation, which has an ongoing impact. So how do you deal with that as well?
Great question. So we had our early adopters, so we had our champions who kind of were, infrastructure intrigued, and they would look through the Backstage doc. They'd be our friendly teams, like the ones closest. They would give it a first pass and point out where we'd missed it, or where we'd assumed knowledge that wasn't actually beyond this particular brain. So they were allowed to. They enriched the documentation that we launched with the things that they were learning and pointed out where it was stale. Then, together with that, we have spun up a developer experience team that steps up to that plate. So I think that answers your question. So we initially invested in it where things needed to be corrected. It could be corrected by the users of the service, and there is now a dedicated function to make sure that stays up to date.
Any more questions? Oh.
It sounds like in platform engineering in general, you often have a product manager looks after the platform, right? Like you were.
I wish that was the truth. I think but continue with your question.
I guess my question was do you think your background in software engineering helped you?
Definitely, yeah.
And what skills would you recommend? And
someone looking into that place, I think. Don't be afraid of it. I started as an engineer. I came into a platform team. The person coaching me as a product manager had never worked in an infrastructure domain. They had been working with things with GUIs or things with user interfaces and external customers. So she found it a bit it was a bit of a mind twist for her to my end user is now a developer. But on reflection, no, it changes nothing. It's the same practice. You're supporting someone's work use case, taking problems away from them. So I would say it's not a different animal. It's the same practice. It's the same practice of product management. It's probably going to be a bit of I would say if you want to go technical PM, that you should try and get some computer science in there, because otherwise it's just, you can very easily get intimidated about something that shouldn't be intimidating. So if you can do, is the short answer, yeah. Anything else?
Oh, I see another question back here.
Oh, cool.
Hey, Debbie, thanks very much for that. Maybe an unfair question. I'm just thinking about if you didn't have that business driver of like the new region, like pulling it all along,
Right.
do you think you could have done it just in the US? That whole changing the behavior and the culture without that kind of big pull, and you were just told, here's the investment, try and make a different pile of mud?
We would have struggled because that money driver was CEO, Chief Product Officer, and Head of Sales, and Head of Finance were all going, make it so. And all of the decisions that had to be made about what do we sacrifice in service of this were made consistently because they believed landing in the EU is worth it, landing in APJ is worth it. So I think we would have struggled, but I think we would have kicked the ball of mud a bit further down the road. But ultimately, that ball of mud was going to bite someone in the ass. I'm not allowed to say that, but I think it just made it faster. It made the need more acute, and there was a carrot rather than a stick at the end of that need. So it was driven by that. I think that was probably one of the reasons why we got the green light and we got it done. Yeah.
Any more questions? Okay, let's give Debbie a giant round of applause. Thank you.
Thank you.